Hello and welcome to Fortinac 8.3 Training, Session 3, Identification and Classification of Rogues. In this section, we're going to discuss a variety of topics, all centered around the identification and classification of rogue devices. So we'll begin the session talking about what is a rogue device and what is a device that has been transitioned from a rogue into a classified device. And then we're going to talk about a lot of the different tools we have that can help us achieve this, such as the device profiling tool, agent technology, MDM integration, manual registration, and importing. And finally, we're going to talk about some system settings that can help you protect all this information once we've gone through and identified everything. Okay, so in this section we're going to understand the difference between a classified device and a rogue. A rogue device is any device that has not been classified with the Fortinac, thus it is considered an unknown device. So this could be something connecting for the very first time that does not exist in the Fortinac's database, or it could have connected at a previous time and it is in the database, but it has never been classified. So it would be maintaining the rogue status. So these are represented in the database as a PC with a question mark. So that's how you can identify when you're looking in the UI that you've seen a rogue. Host state enforcement of rogues is done through port membership in the forced registration port group. So when we talk later on about turning on enforcement, that's the group that's tied to this this host state, the forced registration port group. So what's it mean to classify a device? Well, we take that unknown entity that is connected to our environment. And remember from the previous session with this device ID card, we have a lot of information about the device, an IP address, physical address, vendor name, status. We saw that we gather a lot of that information through the different methods we use for visibility. But all that was telling us what was out there. It didn't classify it as a trusted device. It was just saying, hey, that is out there, that is connected to the network. So how do we go about classifying things? Well, one of the primary methods, especially for Internet of Things, is called device profiling rules. So this device profiling tool uses rules that you create to identify what's connected to the network, and these rules can consist of one or more different methods that are used to validate that the connecting endpoint is what we're looking for. So in this example, we have all that information we had before on the left, but I've added two things here. There's a rule called printers, and this uses Nmap TCP. So this scans devices, the Fortinac scans devices as they come onto the network, and it looks for particular open TCP ports. So that allows us to change from that unknown rogue state into a trusted, this is a printer state. Now we can build as many of these rules as we want, and we can use different methods across them. So an IP phone rule might use Nmap active, which just means Nmap scan, and it's going to look at the operating system details when it does that Nmap scan. And we have a pre-set list in our database of what types of devices will match up with that component of the Nmap scan. So here we've taken an unknown device and turned it into an IP phone. Here I've used multiple methods. So our rule is called access cameras. I'm using Nmap to scan for open TCP ports, and I'm combining that with a vendor OUI. So if both methods are true, then we've identified that unknown device as a trusted camera. So anything completely unknown is called a rogue, and things that have been classified will be classified by the type of device they are. So let's take a look at device profiling rules. We're going to understand what a device profiling rule is, how they work, and then we will see how we can create them to assist us in the identification of unknown endpoints that are connecting to our environment. So at a very high level, the device profiling tool gives you the ability to build rules. You build as many rules as you'd like, and you rank those rules in a particular order. And then when an unknown device that has never been seen by the Fortinet before, so this is upon first connect to the network, when an unknown device connects to the network, it is evaluated against the rules. So in this example, it's going to check, does it match the camera rule? No. Does it match the access cameras rule? No. IP phone rule? No. Does it match the printer rule? Yes. So because it matched the printer rule, that rogue is then classified as a printer. Now you'll notice there was another printer rule at step 5 or rule 5, and then rule 6 was an IP phone rule. Those rules were never evaluated. So it will move down the list evaluating against each rule in order. Once it finds a match, it stops evaluating and it carries out a series of registration settings. Any rule beyond the matched rule is not evaluated. If a unknown or rogue device goes through the entire list of rules and comes out the bottom with still not having matched one, then it is added to the database as a rogue and it maintains that unknown or rogue state. So let's look a little more closely at what makes up a rule. So a rule is made up of two components. The first being methods. So these are the different methods used to evaluate a connecting device to determine whether or not it's a match. And the second is the registration settings. So if all methods match or have a result of true, then registration settings will be carried out. So now let's take a look at a little more closely at these two components. First, the methods. As you see, there's a whole bunch of different methods, and we'll go into each of those in a few moments. But to quickly touch on them, we have IP range, which means the device that's being profiled has to have an IP address within a particular range. HTTP and HTTPS, the Fortinet will attempt to connect to the device that has just connected and attempt to connect with HTTP or HTTPS, and it will look for a particular value. So it'll parse the information with a value. These connections can also require login credentials. You can add those as part of the method. DHCP fingerprint. This can work in two ways. One, the DHCP discovery or request that's seen from the device that's about to be profiled can be compared against a pre-existing, pretty extensive database to see whether or not it matches a particular value, or you can customize your own DHCP fingerprint. So you can use that in two ways. TCP and UDP are TCP ports or UDP ports. So those are a port scan is performed, and the TCP or UDP ports that are required to be open must be open. Active is an Nmap scan, and that keys upon the operating system information that's returned from the device when it is scanned. Now, we can rely on an existing database, as I mentioned, same with the DHCP fingerprint, but we can also customize our own active results based on the operating system details. SNMP is an SNMP get against the device. We can just detect if it was successful, or we can look for a match of a value coming back from the SNMP get. SSH this is really powerful. We can connect, or the Fortinet will connect to the device, log into the device. That can be all you require, or once logged in, can issue a command and parse the output. Passive fingerprinting requires direct communication with the Fortinet, and this is a means that can be used to determine the operating system of the connecting device. So this is for rules like that are trying to profile things like a Windows machine or a Mac machine. Location is as it pertains to the topology view. Is it in building 1 or is it in building 2? So that can be a requirement. Vendor OUI is the first half of the physical address. It can also be a vendor name or a vendor alias, which is an alias that an administrative user can set. Agent means the presence of the persistent agent. It means the device that's being profiled has an active persistent agent currently communicating with the Fortinet. And Telnet works just like SSH. It allows to validate either on successful login or upon parsed output of a command. So there's a lot of different methods there. And if you choose more than one method, the methods you choose are ANDed together. Now, some of the methods will have an OR logic within the method, but from method to method, it's always an AND, logical AND between them. So very often, device profiling rules are 1, 2 of these, maybe 3, because it can get pretty granular pretty quickly. Now, once a rule has been determined to have been matched by the methods, then registration settings can be carried out. So there's a variety of options here. We have sponsor notification. Any administrator can be a sponsor, and this notification can result in an email being sent off to that sponsor. So this notification is based on rule. So it's based by the rule. So we could have one sponsor or group of sponsors notified when one particular rule is matched, or we could have different sponsor or sponsors notified when a different rule is matched. Automatic or manual simply refers to the following settings that we're about to talk about. Do you want the Fortinet to carry them out automatically, or do you want it to profile the device but have it maintain its rogue state until a sponsor manually comes in and tells the Fortinet to go ahead and carry out the settings? So these are the settings that will be applied. So we have device type. What type of device is it? It's anything you want. There's a pre-created list of different device types you could use. Things like it's a camera, it's a card reader, it's a vending machine, it's a cash register. I mean, any number of things, environmental units. You can also build your own device types. So there's really no limit to the number of different types of devices you could have in your environment. So device type will tell the Fortinet what to classify it as. Then we have a role value. I mentioned roles in previous sessions. So a role is really an attribute, and users and hosts and devices can all have a role attribute. And this role attribute can be leveraged with things like policies. So we could have a network access policy. So let's say we were building a device profiling rule for a camera. The device type might be camera, or well, probably would be camera, but then the role, you could set that to say camera. So any device that is matched by this rule will be modeled as a camera and will be given a role of camera. Now, we'll see later on how that can be really powerful and how that can be leveraged with security policies. Now, registration to the user. If user information is known about a device that's, say, attempting to onboard, and it matches a rule, and the Fortinet knows the user information, this is typically going to be because of the presence of an agent, for example, then the device can be registered as being owned by that user. So this would be typically be a BYOD type environment, or a guest environment or contractor. You know, something's coming on that's not a corporate asset. There's going to be a permanent association of who owns that particular device. Modeling and group membership. So modeling is where we can decide how we want this thing modeled. Do we want it modeled as a device in the topology view, which would put it in our topology tree? That's not a real common selection. We can also have it modeled as a device in the host view, which means it's really a host, but we use the term device and host to differentiate between something like a camera versus a laptop. So this would be a device in the host view. So it's a camera, but it's going to be treated as a host. that's going to be 99% of the time you're going to be doing model it as a device in the host view. We can also model as a device in the host view and the topology view. And that wouldn't be that common, but if you did model it in that way, it would still technically be a host, and we would just be showing it up in the topology view as well. Group membership is a Fortinet group. So you could build a host group called cameras, and you could automatically have everything that matches the device profiling rule be modeled as a device type camera, assigned a role of camera, and added to a group called cameras. We could also do, remember, locations, one of the options. We could have different rules for different locations, and all the cameras in building 1 would have a device type of camera, a role of camera, and be added to the group cameras in building 1, where in building 2, they'd be added to a group called cameras in building 2. And this is just a way we can organize them, but it's another way we can also leverage our security policies, because security policies can key upon group membership. So that's another way we can tie pieces together, functionality together. Access availability is simply time of day and day of week that we want to allow this on our network. So you can limit when things are allowed on the network. And rule confirmation, this is really kind of a tool to prevent spoofing. That can be done on Connect. So every time, when a device is profiled, it matches a rule and it gets profiled by that rule, the Fortinet remembers which rule it matched. So in the future, you could set this so that upon connect, so if that profiled device, we'll say our camera, ever disconnects from the network, when it reconnects, we can have the Fortinet reevaluated against this rule, this camera rule, to validate it still matches all the criteria it needs to. We can also validate based on a user-defined time frame every 2 days. If it does, even if it never disconnects, it just stays connected, it can still be reevaluated. And then the final option for rule confirmation is if it fails the reconfirmation. So it originally matched as a camera, it disconnected, it came back on, it doesn't match that rule again, for some reason it no longer matches, we can have the Fortinet automatically disable it to prevent anything gaining access to the environment. So maybe someone was spoofing the camera's physical address. It's important to efficiently rank your rules. Now, this is a best practice, but there are exceptions to this best practice. But as a general rule of thumb, we want to make the evaluation of our rules as efficient as possible for the Fortinet. So we break the different methods into 3 different categories, or 3 different groupings. So over on the upper right, you'll see I have 3 different groupings indicated. I have a collected, a read, and a received. And if you look to the left, you'll see what those will contain. So collected group should be anything that uses nothing more than vendor or location as methods. This is because these are the easiest and quickest to evaluate, because there is no need for the Fortinet to go gather additional information. If they only have vendor or location, or a combination of those 2, then the rule goes into the collected group. If the rule contains any method that requires an IP address, that's something that the Fortinet needs to go out and get. The Fortinet will need to go find the IP of the device being profiled in order to validate that it is what we're looking for. So any of the methods that require IP address, which is pretty much all of them other than vendor and location, and DHCP fingerprint at the bottom. So any method requiring IP goes into the red group. Then, as a third group, we have the received. So this is information that the Fortinet must have received. It does not have the ability to go out and get that information. It is reliant on something in the endpoint to get that information to it, essentially. And the only one that falls into that category right now is DHCP fingerprint. So any rule, vendor location only are the methods, collected group. Anything that requires an IP even if it also has vendor location, if it has a single method that requires an IP, then it goes into the read group, because we have to go read that information. If it uses DHCP in conjunction with anything else, a DHCP fingerprint, it goes into the receive group. So once we've broken our rules up into those three groups, we then sort within the group, putting the collected on top after they're sorted of the read, and putting the read on top of the received as they're sorted. So in the bottom half on the right, you'll see an example, and I'll explain why we've done this. So we only had one rule that required or used vendor and location only, and that was our cameras rule, and it was strictly relying on vendor OUI. Okay, that was the only one, so we put that right at the top. The reason for that is it is so fast for the Fortinet to go through and validate that, because it's information it already has. As soon as it saw something connect to the network, it already knows the vendor OUI. Then our second group, the read group, well, we have 4 rules that fall into that. We have the access cameras, which uses vendor OUI, TCP, and HTTP. And we have IP phones, HTTP, printer, TCP 550 or 9100, and 9100, and the printer rule that relies only on or only requires TCP 9100. And then we have one rule that falls into the received category, and that's an IP phone rule that's requiring or relying on DHCP fingerprint. So why did we put them in this order? Well, number one, I already mentioned that. It's the easiest thing for the Fortinet to evaluate is vendor OUI. Rule 2, the access cameras, OUI, TCP, and HTTP. Well, the reason that we put the access cameras rule in the number 2 position is because one of the methods is vendor OUI. So this can make the evaluation much quicker. So when the Fortinet is evaluating against this rule, the first thing it checks is, does the vendor OUI match? If it does not match, it stops. It doesn't bother going through the other methods. So that's a great way to organize this. If the vendor OUI does match, then it moves forward and tries to see if the TCP and HTTP match. The next one down is HTTP. We could have chosen how we wanted to do this. This one didn't really matter as much, so we just put that IP phone there. Then I have 2 printer rules. The top one is going to be matched if the rogue being evaluated has TCP port 515 and 9100 open. So that's going to catch all printers with both of them open. If there's a printer that does not have 515 open but does have 9100 open, that's going to hit a different printer rule. So maybe we want to handle these differently. And then down the very, very bottom, if a rogue that's being evaluated has come all the way down through the 5th rule, then we're going to go and see, okay, do we have a DHCP fingerprint that matches the method? If the Fortinet does not, then it's going to wait. And it's going to wait only for so long before it finally says, okay, I don't know if this matches a rule or not. And then it will stop evaluation and it will go into the database as a rogue. So again, there may be exceptions to this rule, but as a general rule of thumb, break all your rules, your device profiling rules, into 3 groups. Ones that are in the collected group, the read group, or the received group. And then go inside of each of those groups and organize them, and then they'll all stack up like we see here. So again, this is a best practice, but there may be an exception or 2 to this every now and then. But this helps for efficient evaluation as far as the overhead required to determine if the rule has been matched. So the device profiling view is under the hosts menu, and it's device profiling rules, and it's going to be the down the bottom of the hosts menu. So this is what the view would look like. There's several rules already created and enabled. There's also some in there that are disabled. By default, you will always have, when you first get the Fortinet, it's going to have a list of default rules that are disabled. You can go in and turn those on, but or create your own. So a few things here with the UI is, one, up at the top left, we have the rank buttons. That allows us to select any rule and move it up and down in the rankings. there's also a set rank button right next to those arrows, which will allow us to have a rule immediately jump to a particular rank location. Down on the bottom, we have the add button, which, as you would guess, that is how we add a new rule. And over on the right, we have a run button. This is important, and it's an important concept to know. When a rogue is seen connecting to the network for the first time, it is evaluated against all enabled rules. However, if a rogue already exists in the database, it's never going to be evaluated against all of the rules. So what you're going to need to do is, once you've built your rules all out, assuming there's already rogues in the database when you go through the process of building your rules, once you've built all your rules out, you then use the run button, and that will evaluate all rogues in the database against all those rules in their order. And from that point forward, as each new rogue is identified on the network, that new rogue will be evaluated against the different rules. So the only time you would really need to use the run button is after new rules have been created. Because once they've been created and the run button has been used already, then any new rogue is going to get evaluated automatically as it comes onto the network. So now we'll take a look at the creation of a device profiling rule, or at least the different fields that we would set up through the UI. So here we see up at the top, we've got an option to enable the rule. So only rules that are enabled will process rogues to see if they match. Gave it a name, a description, a note, and then you'll see at the bottom of that selected area, we have a notify sponsor. So any rule can be set up so that a sponsor is notified. And a sponsor is an administrative user. And we can do this on a rule by rule basis. This middle section you'll see, is our registration settings. And the very first option is, do we want these settings to be carried out automatically, or do we want it to be a manual process? So the difference is, automatic is the Fortinac's just going to carry out all the following registration steps as soon as the rule has been matched. Where manual, the rule will still be matched, the device will be profiled, but the registration settings will not be carried out until a sponsor, most likely, logs into the UI and tells the Fortinac to register the system. So what we normally see in a real deployment would be during an initial identification and classification of rogue devices, we see a lot of the device profiling rules would be set to use automatic, because there would be potentially thousands and thousands of things out there we're trying to process. But after we've gone through that identification process and classification process to the point where we have almost everything identified, then it's pretty common to change it over to a manual so that anything new coming on can be validated by a sponsor. So as we go down these settings, you see below that we have type, so what type of device it is. There's a whole bunch of pre-created types. You can also create your own types, which we'll see in a little bit. That makes this completely flexible regardless of the environment it's in. We can define a role to a device. So a role is just an attribute, and a role value could then be leveraged in a policy, for example, maybe a network access policy. So in this example, I could have a network access policy that's configured so that if a connecting device has a role of camera role and it's connecting in first floor building 1, then I would put it on a particular VLAN. Register as, we have a few options there. We have device and host view. That's going to be the vast majority of the time. It's going to be a device in our host view, which means it's just a host that doesn't have ownership. There's other options such as device in the topology view. That would be more of infrastructure devices or something along those lines, maybe something that you want to appear in your topology tree on the left side of the topology. We can see right below that we can add these things to a group. So I could have a pre-created host group, and everything that matches my rule goes into that host group. This is nice. It keeps things organized for one, but also groups can be leveraged in policy as well. So we could almost do that previous example. Now I could say if it's in the IP cameras group and it's connected to a first floor in building one port, then put it on a particular VLAN. So we can leverage the groups just like we could leverage the role attribute. And then there's access availability. So I could say that anything that matches this rule and is then modeled is only allowed on the network during certain times of the day or certain days of the week. So we can limit when it's allowed to be connected. And then down the bottom, we have our rule confirmation settings. So whenever a rogue is processed through and found to match a rule, whatever rule it matched, device profiling rule, is going, we're going to remember that. The Fortinac's going to remember that that particular device matched the camera rule, for example. And then the first checkbox there is confirm device rule on connect. So that means if that camera that we profiled disconnects and goes to a down state and then reconnects, the Fortinac's going to go, okay, it is just reconnected. I need to evaluate it against the rule again. And the checkbox below that is not dependent upon the device going offline and coming back online. It's just a hard set interval, a user-defined interval. So in this example, every 2 days, I'm going to reevaluate that camera and make sure it still matches this device profiling rule that it originally matched. And the last option there is if it ever does not match, then I can disable the device. Now, a lot of this is around trying to prevent spoofing or something like that, trying to prevent something that is masquerading as something it's not, that had been device profiled. So these are all our general settings. And now if we go look at our methods, you'll see on the left-hand side, you select whichever method you want. Now, if you select more than one method, they are ANDed together. So method to method is a logical AND. Then on the right, there'll be a tab for each of the selected methods, and you can go in and set the specifics or the particulars of what you're looking for with that particular method. So in some of the methods, we have OR situations, logical OR inside the method tab, but from tab to tab, it's AND. So let's take a look at the different methods. The active method is it's an Nmap scan of a connected host. And we have a database that looks primarily at the operating system detail information that comes back from an Nmap scan. We have a database already in place that's pretty extensive and will identify something as it comes on and gets scanned, say, oh, that's a camera or that's a printer or something like that. But if we want, you'll see there's a second option, match custom. You can go in and add values that you're looking for in the Nmap scan in the OS detail section. And this makes this completely flexible, is very customizable to any environment. DHC fingerprint is that is the evaluation of a DHCP discovery or request that the Fortinac sees. And just like with the Nmap previously, we have a database. The Fortinac has in its database a large list of fingerprints, and these fingerprints are identified because of option lists and parameters and things that make up the DHCP discovery or request. And we can identify a lot of different things. Fortinac can identify a lot of different things based on that fingerprint. But once again, to make this completely flexible, we've given the option to match a particular custom attribute. And then you can essentially build your own fingerprint and have it have that model as a particular type of device. HTTP and HTTPS, this allows us to configure this so the Fortinac will attempt to open a connection with the device it's trying to profile on the particular port you choose and using the protocol you choose. And we can have it attempt to load a page of a particular path. So here I have it loading /start HTML. And I have an authentication, which is a username and password. So if the page requires a login, then we would have to put that there. And then I have my match value that I can choose to do. I can just rely on it being a successful connection. But in this case, I'm looking for Axis cameras. So I'm going to log in to something, and if it responds and can successfully log in, then I'm going to look at the information that the Fortinet parses from the page and see that if it contains the word Axis, then that's going to be an Axis camera. IP range is exactly what it sounds like. If the device being profiled has an IP address, and of course that would be determined through L3 poll, if it or agent or something like that. But the Fortinet would need to know the IP of the device it's profiling, and if it had an IP within that range, it matches that method. Location is as it pertains to the topology view in the topology tree. So these are the containers you built and where the infrastructure was modeled, and this is keying on point of connection. So is the device connecting to a port, say, of a switch that's within the building 1 container or the building 2 container in this example? Passive fingerprinting uses something called P0F or POF, and it requires communication to take place between the Fortinet and the device being profiled. And as part of that communication, the Fortinet can determine the operating system of the endpoint it's communicating with. Now you see there's nothing for you to set here. This goes back to the General tab. So on the General tab, we have one of the things we have to set in the registration settings is what type of device this rule is going to be identifying. So what the passive scan does is if the type on the General tab was set to Windows, for example, and communication between the Fortinet and an endpoint determined that was a Windows machine, then this method would be a match. So this is tied to the device type selected on the General tab. The persistent agent is simply checking for the presence or identifying the presence of a persistent agent. This is a Fortinet persistent agent installed on the endpoint it's trying to identify. So this requires successful agent communication from the device that's being profiled. You again see there's nothing to set here. There's no values we need to set because it's just dependent on successful communication from an agent installed on that device. SNMP allows an SNMP get, and then if we choose to, we can evaluate the data that was returned and decide whether or not we want to consider it a match. So here I've got an OID designated at the top and the port number, and SNMP V1 and V3 security string we can set there for V1. And what it's going to do is do that get, and then if you want down the bottom, you can choose to match a particular value that's returned. So in this example here, I kept this very simple, but this is just grabbing the sysobject ID from a device, and if the sysobject ID matches what we see down at the bottom there, then this method is considered matched. SSH. The Fortinet will attempt to SSH into the device that it's evaluating. The credentials at the top, you don't see the password here, but in order to add credentials in the top section, you need to have you will have to have the username and the password, but it only shows the username when we're looking at the screen here. And then the middle section where it says commands is what commands, if any, do we want to execute. And you'll notice the first command under type it says expect, and then under the command field it's got a colon tilde bracket. Well, what that's doing is that's telling the Fortinet, once you log in, wait till you see this. And that's actually the end of the prompt for in this situation. So once the Fortinet logs in, it waits to see the end of the prompt, which is in this case colon tilde bracket. Once it sees that, it knows it's okay to proceed now. And it moves on to the next step, which is a send, and it sends ESX CLI systems version get. So that's the command the Fortinet's going to issue at the command line. And then what I've chosen to do at the bottom, where you see I have a check next to match, is I said, all right, whatever comes back from that command, I want to parse it and look for this value. And you see the value there. If that's a match, then our method is a match. Open TCP ports. So the Fortinet will scan for open ports. If more than one port is designated in this field, then all ports designated must be open. So these are ANDed together, these ports. Telnet works exactly like SSH. As you can see by the fields being the same fields, it works exactly the same way. And UDP works exactly like the TCP. The ports have to be open, and if there's more than one listed, then they must all be open. It's a logical AND within that ports field. And we've got vendor OUI. So vendor OUI really allows us to key on a few different things. In this example, you'll see I'm keying on a vendor name, and I have a specific value there for the name I'm looking for. This name is going to exist in the Fortinet's vendor OUI table, and we're going to see where that is. But we can also key on an alias, for example, and we'll see how we can set an alias for a group of vendor OUIs so that we can match on just that specific set of vendor OUIs based on an alias, or we can match on a specific vendor OUI, and we'll see that in a few moments. So once a device has been profiled, it will be added to the profiled devices list, and this is located under the hosts menu. So this is going to show you every device that had been profiled, and you'll see the name, the rule name that it matched, what type of device it is, if a role value is assigned, IP, physical address, location information. You'll also notice one of the fields one of the columns is registered. So that means, is this device currently registered? Was it registered through the device profiler? These all say yes. This is probably the result of the rule being set to automatic registration, but it doesn't have to be. If we had a rule set to manual registration, remember that's one of the settings there on the general tab. If we had that set to manual, then what we would see over under the register tab is no, it's not registered. Just say no, and this is where you would come to manually register that device. You would come in here, select the entry, and then down on the bottom left, you'll see there's a button called Register as Device. When that button is clicked by presumably the sponsor or any admin user, then the device profiling process will complete, and all the registration settings that have been defined within the rule will be applied to that device. Which brings us to device types. So I mentioned there's quite a few different devices out of the box set up in the system that you can use as a way to classify the different things being identified. And this isn't only for use with the device profiling tool. You can manually do this. Anytime a device type must be assigned to an endpoint, this is the list that will be available. Well, there's quite a few on there. There's a lot of different things, medical devices, and you'll see there's cash register, environmental control. There's a lot of different things there. But if you have something in your environment that's kind of unique and you'd like to have it represented as such, you have full capability to come in here and build your own device type. And all you do is use this add button down the bottom of the screen, and then you just give it a name. That's going to be the name of your new device type. And then you can upload a small icon and large icon. So it needs a small, needs a large. They've got to be exactly that size. If you don't want to go through the trouble of getting your own icon together, you can use the Select from Archive option. That button will bring up a list of approximately 1,500 different icons. And it'll be each one will have a large and a small representation, and you just select from the archive and bring it up. So it's really very simple. And once we hit OK here, we will then have that new device type as an option for both our device profiling tool as well as any type of manual registration of a device or classification of a device. And we also talked a little bit about the vendor OUI. So that's a pretty common method to be included in a device profiling role. So the vendor OUI database within the Fortinet is pretty extensive. So we have a filter right up at the top. And here you've seen I've done a quick filter for Intel with an asterisk. So anything that contains Intel. So you see I have Intel Corporation. I also have intelligent control systems and intelligent systems. So I can come in here and I could use in a device profiling rule just a specific vendor OUI like you see over on the left. I could use a vendor name and I could use wildcards to key upon the vendor name. I can also use vendor alias. And you see alias is an empty column in this example. What you would do is select whatever vendor OUI you want to set an alias for. You can either double click on it or use the add button. Use the modify button, modify. And when it comes up, we can set our vendor alias. You see it right there. I've set it to camera. And this is really, really useful if you have multi vendors supplying your cameras, multiple vendors supplying your cameras, and they all, or you just have a lot of cameras that have different vendor OUI values. You can just go in and set the alias for each of those. And as you create your device profiling rule using the OUI method, you can just key on that alias. So even though there's 4 or 5 different vendor OUIs, perhaps they'll all be included within that single device profiling rule. So the device profiler is very often used for those headless devices and things that are out there, such as your cameras and your card swipes and any number of different things connected to the network. But it's not as often to use it, or it's not as common to use it for end stations such as laptops and desktops and iPads and all the different mobile devices. So we very often will use agent technology for identification of those devices. So we'll look at a couple agent options. We have the passive agent. So the passive agent is for use in environments where domain login is part of the requirement. And what we do here is we install an administrative template that's available from the UI of the Fortinet. We install that administrative template on the Active Directory server. Then we get the passive agent executable, which is an exe file, also off of the Fortinet. We can get this through the UI. And we place that executable in a user accessible location so it can be executed during login. Create a login script that executes that. And the administrative template configurations will be the fully qualified domain name of the Fortinet. This is so that when the passive agent is executed by the login script during user logon, it knows who the Fortinet is. It knows how to talk or how to communicate back to the Fortinet, because what it's going to do is it's going to send back all the host information about the host it just ran on. So this would be physical interface information, IP address information, host name, operating system. It can also perform a scan and report back scan results. Okay, so these are the settings that would be set up on the Active Directory. For example, you'd install the administrative template, configure the template with the fully qualified domain name of the Fortinet. Then you would put the agent executable out in an user accessible location, and then you would build your login script to automatically execute that agent when the user logs in. That's step one. The next piece is configured within the Fortinet, where we go under the policy menu and select passive agent configurations, and we create a new agent rule. And you see there's one there already, but what this is going to do is this is going to explain or define for the Fortinet how to handle the different hosts when that passive agent runs and reports the information back. So you would select add to create a new rule. I've enabled the rule. You would enable at the top, give it a name, and then you see apply to members of group, and I have engineering selected here. That group is a AD group. It's an LDAP group. It is not a Fortinet group. It is an LDAP group. So once we get the user credentials from the agent, when the user logged in and the agent ran as a part of the login script. We can then see if that user is a member of a particular group, and if they are, so say they are a member of engineering, then the Fortinet is going to handle this registration in the following ways. It's going to register as a device, which means it's not going to assign a permanent association between this user and the device. So it's not like a BYOD device that the user owns. It's perhaps a corporate asset, and we're just going to we're going to change it from a unknown rogue into a trusted asset because we know it's got domain access. The user just logged on to the domain. So we can also scan unless it's previously scanned within a certain period of time. Here I've set 24 hours, and the scan, which defines the requirements, those are defined in the scan. I can system assign scan, which means a policy is assigning the scan that this host must adhere to, or I can select a specific scan from a drop down of existing scans. The scan is just it's going to define the success criteria, basically what the end station must comply with in order to get on. This would include things like particular antivirus, virus definition levels, running processes, things like that. And then we can choose to have the host added to a Fortinet group. So in this case, it's being added to the engineering hosts group, which is a Fortinet group. Another type of agent is the persistent agent. So the persistent agent has many different flavors. We have executable, DMG, DEB, RPM, MSI. These are the one you use is going to depend upon your method of deployment. So most often, the persistent agent is going to be deployed as part of a group policy. It's going to be pushed out as part of a group policy. It's going to be made part of an image, or it's some other software management tool is going to push the agent out. Now, if you're going to be pushing it with group policy, you're going to need that administrative template installed, just like we did with the passive agents, the same template, so that when the agent is installed, it knows who the Fortinet is. It knows how to communicate back to the Fortinet, knows the Fortinet's name. If you're pushing this out using some other tool, then it's also going to require that you push out a handful of registry entries. And those registry entries are what tell the agent who to communicate with, and some other options as well. You could also deploy this through the captive portal. That's not as common, but it could be done. You would use the executable in that situation, and when someone is isolated to the captive portal, they would download and install the agent, and the agent would get itself configured because it would communicate with the Fortinet directly while in the captive portal environment. So the persistent agent maintains communication with the Fortinet. So at an interval, it communicates back to the Fortinet, and the Fortinet acknowledges that the communication came in. So that's a important piece. It's always reporting back each time it reports back information about the interfaces, information about the operating system, and things like that. It also allows for background scanning. So if you have a policy in place where you want to scan your endpoints for compliance, say every week, using the persistent agent can make that process completely transparent to the end user, because they won't even necessarily know the scan has taken place. So that's a nice advantage of the persistent agent as opposed to some other agent option like dissolvable agent, which we'll talk about later. And this also gives us the ability for system messaging. So the agent has a built-in messaging component that an administrator can send a message to a host that has the persistent agent and have that message appear, pop up on the screen of the host. Integrating an MDM with the Fortinet is another method we can use to identify hundreds or potentially thousands of mobile devices. There are currently 4 vendors supported for integration with the Fortinet. That's AirWatch, Mass 360, Mobile Iron, and Zen Mobile. And when the FortiNAC is integrated with those MDMs, what it allows us to do is pull down all of the trusted known mobile devices that are registered within the MDM and bring them down and make them known or trusted devices within the FortiNAC database. Depending on the MDM vendor as well, we could pull down an application list so that we would know all installed applications across all of the different devices. If a device retrieved from the MDM has associated with it a user who has an email associated with a user in the FortiNAC, that device will be added as a new device owned by that individual user. So if you've already got a laptop system registered to a user in the FortiNAC, and then a integration with the MDM occurs and it pulls down 2 more mobile devices, and those mobile devices in the MDM are associated with a user whose email is the same as the user in the FortiNAC, it'll just put all those devices together. So that single user would now have 3 devices, the 2 mobile devices and the laptop. We can also apply security policies to mobile devices based on attributes that can be retrieved from the MDM, so that we can have, say, network access policies, for example, already configured and in place, so that when these MDMs connect to our environment, they're provisioned correctly. And there are additional columns of information within the host view specific to MDM details, such as, is the device still compliant with the MDM? The integration is very simple. You go under the system settings, so it's system menu, settings, and on the left you open up the system communication folder, and in that folder you will find the MDM services settings option. You select that option, and then you can use the add button to add a new MDM integration. So the MDM vendor is one of the 4 I mentioned. You give it a name, and then the communication information that's required for the integration to succeed, and for the two things to talk successfully together, the FortiNAC and the MDM. And then we can choose some additional options at the bottom, which are normally just left all selected, but enable on-demand registration. So as soon as we see a new mobile device in the MDM, we will automatically make it a registered or trusted asset within the FortiNAC. We can revalidate the health status. So each time the mobile device connects to the network, we can validate with the MDM that that is still in compliance with whatever policies are in place at the MDM or on the MDM. We can delete hosts from the FortiNAC if they're removed from the MDM. We can update new applications on the different hosts that have been learned by the MDM, and we can set how frequently the FortiNAC goes up and synchronizes with the MDM. Another option for identifying and classifying is to do it manually. So it's very simple to go in as an administrator or as an administrative user, given the appropriate rights through their admin profile, to go in and manually register hosts that are seen on the network. So all you would do is find the host in the host view. You would right-click on the host, and then you can select to register as device or register as host. So if you're registering it as a device, that typically indicates that it is not owned by an individual. It's not a BYOD device. It's probably a corporate asset. You may then, going forward, track which users are using it, but it's not a BYOD type device. Or we could register the host to a user, and you see both options on this screen at the top. If we register to a user, that's typical of a BYOD device. We're saying this laptop is owned by this individual, and that's always going to be the case regardless of who's using it at any given point in time. It's got a permanent association. So that would normally be guests or contractors or students or something like that. Now, you can also import large quantities of devices. So this is a nice option when you have a large number of hosts that are going to eventually be on or within the environment, and you already have the information, particularly like the physical address and things like that of those devices. So we'd use this import button here, and that will give you the option to choose a CSV file and bring it in. And this is a common method for things like Chromebooks or something at a school. They get 500 Chromebooks. They will already have access to those 500 physical addresses for the interfaces and things like that. So they can use this import to very quickly bring those in as trusted devices. You're just going to need to define what each of the columns in the CSV mean. So we'll take a quick look at what pieces of information you can bring in through an import of a CSV file and how we would set up that CSV file. So you'll see here on the left we have adapter fields, host fields, and user fields. So the pieces of information you want to bring in, you have to have the column title, the first row in or first entry at the top of the column has to be for adapters. It can be adapt.ip or adapt.mac. Adapt.mac is going to be required because that's how it's going to be identified. Then we have host fields, and you can have that information. You have user fields. So you take the information you have, you organize it into the columns with the appropriate headers at the top of the column, and then you save it as a CSV file, and you can import it through that import button we saw on 2 slides ago. Now that we've spent all this time identifying and classifying endpoints that are connecting to our environment, let's take a look at some system settings, a couple of which are going to help us preserve that information in the event of a disaster or something. We'll be able to have that information kept safe. So one of the first settings we're looking at here, so I've gone under the system settings under the system management folder on the left. One of the first settings we see, or the first setting we see, is this database archive. So what this does, if you look at the top screen capture, it says remove local backups from older than 90 days. So whenever the scheduled task runs, and the scheduled task is called purge events, and the scheduling or running of it is done on that same window there, and just below the blue bar. And what it will do in this case, we have connection age time, event alarm age time, and scan results. So these are administrative views within the Fortinet. There's a connection view, an event view, an alarm view, and a scan results view. These views tend to fill up very, very quickly because lots of information can get posted into those views. And when you, as an administrator, load one of those views, it can take a long time if there's a lot of entries. So what this will do, as you see they're each set to 7 days, each time this scheduled task runs, it will take all entries in any of those views 7 days old or older by default, and it will archive them into the database. So it'll take them out of the view that loads, so the views will load faster, and they'll still be available if you need to go back. You can import any of those archives from within each of those respective views. The second one down is our database backup and restore. So this is by default going to delete any databases that are 90 days or older each time the scheduled task runs. The scheduled task is set right there as well. You can run it at any point as well with the run now. And then down the bottom we see all backed up databases. So you can select any one of those and do a restore database, and it will back up the current database and then restore the selected database. High availability is if you're going to have multiple Fortinets, one as a primary and one as a failover. In the event that something goes wrong with the primary, the failover can take over. There's 2 different methods of doing that. You can do it in what's called L3 high availability or layer 3 high availability, as well as layer 2 high availability. This is where that information will be configured. And then we have license management. so you can see what information or what license details there are to see, how many concurrent licenses are there, whether high availability is an option, whatever your license key provides. You can also modify the license key from within this view. NTP and time zone settings are just done through the NTP and time zone page. And then we have a power management page. This is where we can reboot or power off the appliance. Remote backup configuration is if we want to have our database as well as our system backups, if we want copies of those things pushed off to a remote location, which I would always recommend. Push them off to a remote location so that in the event of a catastrophic failure, you won't lose your database and you won't lose the system settings that will be needed for a quick recovery with a new system. So you can see the remote backup configuration. We can do it through FTP or SSH. And the system backups is a scheduled task as well, just like the database backups. That will run and back up the settings and configurations that don't exist within the database. And that concludes this session.